So today, just in the earlier class, we have discussed about the relative address. Okay. So what is relative address and what is jump operations, how they are going on, and forward jump and backward jump. Both of them we have discussed. Okay. So now we will see some sample program so that we can better understand the how to write a program. Okay, so firstly this we will take write a program in 8051 assembly language programming to transfer 10 numbers in the internal RAM starting from 30H from external RAM. Data are stored from memory location 8050H. So the meaning is the source, look at the copy, look at the copy. So the problem is we need to transfer a data. The number of data is 10, 10. Okay. So, and the external RAM from external RAM to internal RAM. Okay. So this is the our from here to here transfer 10 data. Okay. So this is the problem. So from external RAM to internal RAM, we need to transfer 10 data. This is the problem statement. And here also we will see that the external RAM will be starting from 8050H memory location, and internal RAM area will start from 30H memory location. Okay, so from this figure or from the problem, we can clear understand that from 80H memory location, the data is to be stored into 30H. 8051H will be stored into 31H. 8052H will be stored to 32H, and so on up to 8059H. Okay. Clear or not?
Yes.
This will be stored into 39H. Okay. So this is our objective. Clear? So to achieve the objective, we need to initialize those memory location in internal RAM as well as the external RAM. Okay. And here, what are the instruction used? What instruction are to be used during this external and internal RAM transfer? Can anyone tell?
ORG 000H.
Okay, so this is the starting program. I mean, starting line of the program. It indicates that the program will be starting from 0000H, or the content of the program counter will be 0000H. So first we initialize. How to initialize? The microcontroller should understand that 8050 memory location and 30H memory location, right? So to initialize, what we need to do?
The data pointer register we will use.
Very good. Okay, so we will see the first one, that is move dptr hash 8050H, because this is the only 16-bit register that is available in the 8051 microcontroller. Okay, so dptr is loaded by 8050H. Okay, fine. So next, what will be there? what will be there? Look, we need to initialize a counter also. Okay, so to initialize the counter, we have taken as move R5 comma hash 0AH. A means 10. Clear? A means 10. So we need to transfer 10 data. So this is the counter. This will act as a counter. Okay. Next, we need to initialize the internal location, that is move R1 comma hash 30H. Clear? Clear or not up to this, up to these 4 lines?
Yes, sir. Clear.
Okay. Now what we need to do? Next task to be done. What is to be done? Now, what is going on here in this instruction, particular instruction? Look into the PPT. MD Imran. What is the operation going on here in the in this movex a comma at the rate dptr? MD Imran. MD Imran, please respond. You are not audible. Please tell it so much louder. Pradeep Singh. Pradeep Singh.
Yes, sir.
What is going on in this particular instruction? This movex a comma at the rate dptr?
No.
Monica Nagar.
Sir, external memory moved through accumulator.
External memory has been moved to accumulator. Is that so? Is correct?
No, sir.
Sir, the content at the address of DPTR will be moved to the external register A.
Very good. So there is one operator, that is at the rate. Okay. So we will take move x a comma at the rate dptr. That means the content of the memory location that has been located by dptr register, that will be moved to a register. And as this is located in the external RAM, so we have used movex. Clear? Okay. So in the next one, the content is to be moved into 30H memory location. So we will use move at the rate R1 comma A. That means the content of A register that is moved to the memory location that is located by R1 register. That means 30H memory location. Clear? So first data has been moved. So now what we need to do? We need to increment this DPTR. I mean increment this particular external memory location as well as the increment the internal RAM location, and simultaneously decrement the counter, because one data has been already transferred. So how many datas are there to be transferred? 10 datas.
9 data.
9 data. So this needs to be decremented. Okay, so 3 operations will be going on simultaneously. So first INC DPTR, then INC R1. Okay. Then now we will use some new instruction. Just we have not discussed this, so I'll discuss it just now. DJNZ means decrement and jump if not 0. Write in your copy DJNZ, that means decrement and jump if not 0. Okay. Now here in the instruction, it denotes decrement the content of R5. Clear? Decrement the I'm repeating once again. DJNZ R5, that means here decrement the content of R5. This is the counter. Okay. Clear or not? Am I audible to all of you?
Yes, sir, clear.
Yes, sir.
Okay. So decrement the content of this R5 and jump if not 0. Okay. That means R5 content was 0A. So here the R5 content after the instruction, the content of R5 will be 09. So 09 is not 0. So this condition is satisfied. Decrement and jump if not 0. That means the content of R5 will be decremented by 1, and it will check that whether the content of this R5 register is 0 or not. If not 0, then jump to particular relative address. So what is the relative address? Suppose here
Back.
yeah, back. So back will be here. Why, sir? Why here? Because now the content of DPTR is located towards 8051H, and after the first iteration, this will 31H, 31H. Okay. So now our objective is 8051 to 31H. So same operation is going on because DPTR is located at 8051H. So 8051H content that will be moved to the accumulator, and accumulator content will be moved to 31H memory location. Clear or not? And this loop will continue until this R5 will be 0. And when this will be 0, so this will be the end of the program. Okay. Now you can see this particular instruction is acting as the infinite loop. Okay. So this is the infinite loop. So we are using this infinite loop to end the program in the 8051 microcontroller. Clear or not? So any questions you can ask. In the program, if any question is there, you can ask. Rishabh, Mustaq Ansari, Shalini Priya. Tanisha, are you there?
Yes, sir.
Okay, please, it will be good for you if you keep keep tracking of the class, because in the past classes you are not you are present but you are not responding. Okay, from now on,
Okay.
respond, otherwise your attendance will not be counted. Okay.
Okay, sir.
Okay.
Okay, sir.
Okay, so anyone has any questions on this? Okay, so we are moving forward. Now there are some assembler directives that ORG directives is used to indicate the beginning of the address that also means that particular word G instruction denotes, loads the program counter content to 0000H. Okay. Next comes equate, that is used to define a constant without occupying a memory location. So count EQU 25. That means this particular 25 counts has been loaded into the R3 register. Here I'm just giving a mark. So this R3 register is loaded by 25H, but this particular instruction, this equate instruction, doesn't take any memory location. Okay, this is the advantage of this particular equate instruction, directives, because this kind of directives will only be used while performing any simulation. Okay, but other than this word G, EQU and end, this cannot be used in the assembly language programming. This can only be used in the simulation. Clear? Okay, so we are also, this end is this indicates the assembler end of the source file. So in place of this sjump here, this infinite loop, we can also place end. Okay, so nothing wrong in there. So we are going forward. So there are some other directives too, that is db. Now there are 4 declarations. You can see there are 4 declarations that db is used to define data that can be in decimal, binary or ASCII formats. So for example, here it is written that data byte, db means data byte. Okay, so first data is loaded data byte 28. Okay, so 28, whatever we have discussed earlier also, if we don't put h after the particular number, that 8051 will understand that this number is the decimal number by default. But when we are using some notations, like in the second data 2, you can see that binary data is declared, and after that this b is declared. That means this is the binary number. Okay, similarly in the data 3, h is used, so this is the hexadecimal number. Okay, and whenever this data 4 is loaded, you can see there are parentheses is there. Okay, so this what we are calling it as inverted comma. So this inverted comma is there, so this will be acting as the ASCII number. Is that clear? Is that clear? So this is a very important thing while writing a program. During writing a program, this should be noted that you have to declare this particular number in a particular format among these. Okay, so you can load binary data, you can load decimal data, you can load hexadecimal data, and you can also load ASCII data, ASCII number. Clear? Okay, so perhaps we are coming to an end. Okay, sorry. So let us discuss that this, what is assembly language. This assembly language by which we command the CPU is called an assembly language. It is a series of statement or lines. So whatever we have written in the copy, you can see this is the assembly language programming. Okay, so this assembly language programming, and you may ask that why sir this kind of instruction is developed, why other instruction cannot be done, because it varies over the manufacturer. Okay, so in the manufacturer data sheet, you can find it these instructions. Whenever a processor or controller, whatever processor is there in the in modern world, So with the processors, a data sheet comes. So in the data sheet, there are instructions that are written, and manufacturers let the users know or let the buyers know that what are the instructions are to be used to perform a particular operation, and what are the specifications are available. जस्ट लाइक अगर तुम लोग कोई मोबाइल खरीदते हो या फिर कोई टीवी खरीदते हो, कुछ हेडफोन्स खरीदते हो, तो उसके साथ एक कैटलॉग देता है, एक मतलब एक बुक देता है। तो उस बुक में हाउ टू ऑपरेट, ये सारे चीजें, कुछ हेल्प मैनुअल, ये सब दिया हुआ रहता है। तो दैट इज द मैन्युफैक्चरर स्पेसिफिकेशन दैट हैज बीन गिवन इन द डेटा शीट। ओके, सो these features, there are some features of the assembly language also that one instructions can be written in the one line, and you can give the name of the labels which give the names to the memory location start in the first column. So whenever we are doing the lab, so your lab is there in coming Monday, so we'll discuss it later on. So if you can remember also, in the past semester we have written some programming in 8085 microprocessor, right? So in the 8085 microprocessor we have also seen this kind of activities. Okay, so there should be some comments section, and you can write your comments also, and there are some assembly language instructions we have already discussed, that some sample programs. Okay, so we are not discussing here it again. So just a minute. So here we will see the interfacing between the microcontroller and RAM and ROM. Okay, so you can also remember that has been somewhere it was touched in the past semester. So here just see, this is the size of the RAM. Okay, now here how to understand that in the figure whether it is RAM or ROM. How to understand from the figure? How will you understand that whether this is RAM or ROM? Now look, let me ask, what is the difference between RAM and ROM? Tell me. What is the difference between RAM and ROM?
Here in ROM, only read operation is here.
Okay,
And in RAM, read and write both are present.
very good. So what is this? What is in the figure?
Sir, RAM.
Why?
Sir, read and write both are present here.
Yes, so this is read and write, both are present over here. Okay, so this is the RAM. Okay, I'm erasing all the things. So look into the copy. Here we can see we are interfacing with the microcontroller with 4K into 8 RAM. Okay, so 4K into 8 RAM. So what is this 8? That means 8-bit data can be stored into this RAM. Okay, and 4K, that means that this is the size of the RAM. So how many data can be stored into the RAM? Okay, so 4K, that means this 4K, that means 1K into 4 we can write. So 1K means 1024 into 4. So this means 1024 means 2 to the power 10 into 2 to the power 2. So 2 to the power how much?
12.
12. Okay, so 2 to the power 12 is there. So this was also been discussed. What is the address range of 8051 microcontroller? What is the address range? How many address lines are there in the microcontroller 8051?
Sir, 12.
No. How many address bus are there in the 8051 microcontroller?
16.
16. So we can also remember that 2 to the power 10 into 2 to the power 6, that was 1k into 64, that was 64 kilobytes. Okay, so 64 kilobytes can be addressed by this 8051 microcontroller. Okay, so while addressing 64 kilobytes of RAM, 64 kilobytes of memory location, we need 16 address lines. Like, so in by using these 12 address lines, how much this memory location is 4k, then 12 address lines will be needed. Clear? So 12 address lines means from A0 to
A11.
A11. Very good. Okay, so we will write like, so 16 address lines are there, so we are writing like A15, A14, A13, A12, A11, A10, A1, A0. So there is a complexity of space. So this particular things, this A0 to A11 has been used for the addressing. Clear? So the minimum bit that can be loaded is all zeros. Okay, clear?
Yes, sir.
Okay, so rest of this rest of this 16 that are A12 to A15, there are 4 address lines. These address lines will be used to enable this particular RAM. Now you can see in the PPT, A0 to A11, these are directly connected to the RAM. Okay, to make the, to give the addressing, to give the address. Okay, to give the address of 4 kilobytes. Clear? Now to enable the chip, there is a chip select pin is there. So chip select is, you can see this chip select is active low signal. So whenever in this pin, if 0 comes, then this chip will be enabled. Clear? Now the input will be, so here must be 0, only then this will be activated, and this is the NAND gate. Okay, so NAND gate output will be 0. So when that can be done? That can only be done when the output of the AND gate will be 1. So every inputs will be 1, then only this output will be 0. Clear or not? Because NAND is nothing but the
Yes, sir.
complement of AND gate, right?
Yes, sir.
Yeah. So this will be 1 because this is directly connected. This A12 and A13 is directly connected, but A14 and A15 that are connected over a NOT gate. So this will be 0 and this will be 0, and rest of this will be 1. Clear? So we are putting these values into the copy 0, 0, 1, 1. So these total 16 bits are formed. So what will be the range of this particular address? So these all is 0. So maximum that can vary is all 1. but this will not change. This is fixed because these particular bits are used for chip select. If we change this, then the output will not be there. If we change this bit pattern, so this particular RAM will not be active. So we cannot change this particular 4 bits in this particular interfacing. We will discuss some interfacing in the next class also. Okay. And here you can see this D0 to D7, this D0 to D7, these are connected with the microcontroller for transferring the data between the RAM and the microcontroller. Okay. So this is the microcontroller side, this is the microcontroller side, this is the microcontroller side. Clear? So I'm just marking the microcontroller side again. This is the microcontroller side. Okay. And also this will be there also. This memory read and memory write is also coming from 8051. Okay. Understood or not? So just
Yes.
I mean, go through it. In the next class we will discuss it again. Okay. So just do this. So after recording your attendance, you can leave the class.